Okay, we're looking at section 4.6 in Algebra 2 Honors. I believe it's entitled Solving Logarithmic and Exponential Equations. The instructions for all of these are solved, so I see 36 and I see 1/6. They are both powers of 6. 36 is 6 squared. 1/6 is 6 to the negative 1. You still have these powers outside. And when you do a power raised to a power, you multiply your exponents. So that's 10x plus 4. A power to a power, you multiply your exponents. So that's negative 11 plus x. The expressions are equal. The bases are equal. That means the exponents have to be equal. So you get 10x plus 4 equals negative 11 plus x. If I subtract x, that makes 9x. If I subtract 4, that makes negative 15. Then I would divide by 9. I would notice that 3 goes into both of them. And I think I would cancel and hopefully get a solution of negative 5/3. Anyway, after 9, I'm going to try and do them fairly sequentially the way they're asked, is 11. 25 and 1 over 25 are both powers of 5. 25 is 5 to the 2. 125 is 5 to the 3, but because it's on the bottom of the fraction, it's 5 to the negative 3. Now you still have these exponents out here, 10x plus 8 and 4 minus 2x. Again, if you have a power raised to a power, you're going to multiply the exponents. So I think that's 20x plus 16. Power to a power, you multiply your exponents. I believe that's negative 12 plus 6x. Now, please notice that, what did I do? Did I write it wrong? Yeah. So it should be negative 12 and plus 6x. Does that look better? Now my bases are equal. They're both 5s, right? The bases are both 5s. The expressions are equal. The bases are equal. That means the exponents have to be equal.
Attention, any students going to Zoe's Youth Summit with Hicks, please report to the front of the school at this time. Any students going to Zoe's Youth Summer with Hicks, please report to the school at the front of the school at this time.
So what I did was I took the exponents and made them equal to each other. I'm going to subtract 6x, which I think makes 14x. If I subtract 16, I believe it makes it negative 28. Subtract 6x, subtract 16. So I subtract 6x, those drop off. I'll subtract 16, those drop off, leaves me negative 28, 14x. If I divide by 14, I think that makes x equal negative 2. Okay, I think somebody after 11, somebody had asked 17. This one has an e in it. So I'm going to isolate the x, so I got to divide by 4. That gives me e to the negative 2x equals 17 over 4. I'm rewriting it, leaving a little room because I don't know if you're familiar with it or not, but the inverse function of e to a power is natural log. So if I take the natural log of both sides, whatever I do to one side, I have to do to both sides. The natural log and the e eliminate each other. So that leaves me with negative 2x equaling this. Then to get rid of the negative 2, you could either you could divide by negative 2, or you could multiply by negative 1/2. I really never like fractions in a fraction, so I might multiply by negative 1/2. That would make x equal negative 1/2 natural log of 17 over 4. Now, if I was to punch that in my calculator, at that point it's going to become an approximation, which I use a squiggly equal sign to indicate. So I have -1/2 times the natural log of 17 over 4. As a decimal, it's negative 0.7234. 0.7234. So if they want it as a decimal, I'd put this. I prefer the exact answer, which is the one above it. But if you put it in decimal, it shows me you can use your you know how to use your calculator. Some calculators, like the TI-89, you could just enter it as a solve like this, and it would give you the solution. That's called a symbolic calculator, symbolic manipulator. 21 here, I want to isolate the variable. So I'm going to subtract 1 and then multiply by 3. First I'm subtracting 1, which makes it 5. To get rid of the 1/3, I'm going to multiply by 3. So now I have this. 6 to the -4x equals 15. I'm going to hesitate here to make sure everybody's with me. I'm sorry. The best way to get rid of 6 to a power would be to do log base 6 of it, because log base 6 of 6 is 1. But most calculators do not have log base 6. So what I recommend is you simply get into one routine, natural log it. Then there is a property of all logarithms that allow you to take an exponent and pull it out front. So that makes it into -4x ln 6. The opposite of multiplying by ln 6 would be to divide by ln of 6. You could actually divide by -4 ln 6 if you wanted, because those would all cancel, right? And that would leave me with my result or answer of x equals the natural log of 15 divided by -4 natural log of 6. If you approximate it using a decimal, you'd have natural log of 15 divided by, I use parentheses to enclose the entire denominator, natural log of 6 times -4 gives me -0.3778. Again, the decimal is a decimal approximation. The one with natural logs is a precise answer. I tend to prefer the precise, but again, I'd like you to be able to use your calculator efficiently too. Okay, after 21, somebody have 45, 39, 23. I think 23 is the next one sequentially. Okay, to solve 23, again, I need to isolate the variable. So I need to subtract 7/2. 4 could be called 8/2. If I subtract 7/2 from 8/2, that leaves me with, I believe, 1/2. 3/4 e to the 2x equals 8/2 minus, 7/2. 8/2 minus 7/2 leaves me with a 1/2. Now I want to get the variable by itself, so to get rid of the 3/4, you multiply by the reciprocal, which is 4/3. So that gives me e to the 2x equals top times top, bottom times bottom, 4/6 or 2/3. So I have e to the 2x equals 2/3. To get rid of the e, you use its inverse, which is natural log. The natural log and e eliminate each other. leaving me 2x equals a natural log of 2/3. To get rid of the 2, multiply by 1/2, and you would have your exact answer. Now, as a decimal, it'd be 1/2 times the natural log of 2/3. It would be negative 0.202, negative 0.2027. So that would be it as a decimal. I'm sorry. $39. There is a plus. That means I probably need to use this identity or property. So basically the plus is going to make it into multiplication. X times x plus 3. To get rid of the natural log, you use its inverse function, which is e. When I say e, it's e raised to that power. Again, e and natural log will eliminate each other, giving me x squared plus 3x equals e to the first, which is e. So that gives me x squared plus 3x minus e equals 0. So I solved this on my calculator and found the zeros to be these two answers. Only one of them works, however, because you can't take the log of a 0 or a negative. If you put this into here, it would be the log of a negative, which is not possible. So there is only one answer. I did it graphically. I saw where this particular graph crossed the x-axis, and I found that value to be this. You could have done the quadratic formula. Negative b, which would be negative 3, plus or minus square root of b squared, which is 9, minus 4a, which is 1, c, which is e. Actually, it's negative e. And then all over 2a, which is 1. The quadratic formula from Algebra 1. So you get 9 plus 4e all over 2. Punching that into your calculator, you'll get these two values. And again, only the positive one works. 45, again, the variable I want to solve for is in the exponent. So to get rid of it or to pull it out of the exponent, I have to employ logarithms. I prefer natural logarithms. One of the properties allows me to pull the exponent out front. So I have x plus 1 times the natural log of 3 equals the natural log of 6. What's the opposite of multiplying by ln 3? That'd be to divide by ln of 3. So that gives me this. The only thing left to solve for x is to subtract 1. And so this would be my exact answer. As a decimal approximation, we'll punch it in. So if you punch it in your calculator, you should get about 0.6309. Please resist the urge of calling this ln2 because it's not. Don't cancel the ln's because it's not multiplied. It's natural log of 6, not natural log times 6. It's a mathematical function like a square root. It wouldn't make sense to say what's a square root times 9. You'd say what's the square root of 9. So it's a mathematical concept. 41, I think, is a really good question type. This is the one I know I always ask this type on any quiz I ever give on log equations because it has a couple of the properties that you have to use. What does the addition become? Let me make the addition purple or some other color like red. log base 5 of x plus 1 equals 2. When it's added, it turns it into the log of the product. So you'd have x plus 4 times x plus 1 equals 2. Now I'm going to convert it to exponential form. To convert it to exponential form, we do what some teachers call the fish hook. 5 raised to the 2 equals all of this, x plus 4 times x plus 1. So I took it from a logarithmic formula and I wrote it as an exponential formula. That gives me 25 equals x squared plus 5x plus 4. Subtract 25. That makes it into x squared plus 5x. And what would this be? Minus 21. Are there factors of negative 21 that add to 5? Negative 7 times 3, 7 times negative 3, negative 21 times 5, 21 times negative 5. I'm not sure this thing factors. So we might have to use a quadratic formula again. So, if you don't remember it, here it is again from Algebra 1, negative b plus or minus square root b squared minus 4ac, the entire thing divided by 2a. Remember that this a is a 1, b is a 5, c is a negative 21. So when I fill this in, negative b means negative 5, plus or minus square root of that squared, negative 5 squared is 25. For a is 1, but c is negative 21, all over 2a, which is 1. Negative 5 plus or minus, this would be 25 plus something because it's minus a negative. 4 times that is what, 84? And this is over 2. So you have negative 5 plus or minus, that would be, I think, 109 over 2. You're going to want the bigger of the two numbers because the smaller one is going to create the log of a negative. So your answer, I believe, is going to be negative 3 plus radical 109 all over 2. The other one would, that's not an approximation, that's an exact. The other one would give you a log of a negative if you were to substitute it in. So this is, let's figure out as a decimal, negative 3 plus square root 109. Take that value, divide it by 2, and that gives me x equaling approximately 3.7201, 3.7201. I'll verify graphically now by graphing this parabola. X squared plus 5x minus 21. Again, I like zoom 6 to start my graph. This gives me a couple places where it crosses the x-axis. Let me put this on the projector. Where did I do a 5? Hang on one second. You're right, I don't know how that negative 5 here, this negative 5 right here became a negative 3. It should be really a negative 5, right? So this is not, oops, negative 5. So I think my numeric value is going to be a little different. Let's figure out what that is. So yes, when we did it graphically, we did get this value right here to be 2.72. Or if we did it with the quadratic, you'd get the same value.